can hear me, probably you can use the Q&A section or the chat section to let me know. All right, thank you. Awesome. Great, thanks. I think we are right on time. It's about 11 a.m. IST. All right, we got about 40 participants. So while we are waiting for a few more people, let's get started with the introduction. So just we get familiar with ourselves. You get comfortable with your 2 hours invested on today. Um, I'm Anand. I've been in IT for 15 plus years, mostly working on identity and access management. Well, that's my core strength. If you've heard about identities, Active Directories, Novell identities, Oracle identities, that's my core area actually. So last 7 years has mostly been um, a fight with the cloud, various um, areas, specifically on Microsoft Azure, Amazon Web Services, and lately Google Cloud as well. Again, I'm more on the security side, cybersecurity side of the cloud computing side. So I take care of the cloud security, DevSecOps, on working with the DevOps team to implement security operations. Um, Also, architect and design solutions for various companies is what I used to do earlier when I was a consultant. But at this time, I'm just working with a single company. So I work mostly on governance aspects, could be possibly naming conventions, standards, approach, compliances, regulations, and how to set that architecture and design as per the compliance requirements for that company. Could be banking, probably looking at PCI DSS or FedRAMP if it's a federal risk assessment management program, or if it is a pharma based company, you're looking at FDI or GXP regulations, right? That's very important. Now, when it comes to this particular session, introduction to serverless with a deep dive on container services in AWS. Now, well, this comes in as a passion to learn more areas of the cloud. I've worked with few clients where people wanted to migrate their on-premise infrastructure from, let's say, VMware environment and Hyper-V environment to Kubernetes architecture, so new modern way of designing applications. So we were not doing any lift and shift kind of operations. Yeah, we were just doing um, some kind of a analysis whether this application on-premise fits in, let's say, cloud. You do an assessment, and instead of doing lift and shift, where you just carry your existing loads all the way to on-premise, you will analyze the components one more time, redesign it, and then think whether it's going to fit as a beanstalk application, or will it fit as a container services or Kubernetes services, um, or maybe just outsource the whole application to a different provider. Well, that's a kind of analysis that was done probably 8 months ago, and that's where serverless comes in my portfolio. We have quite a lot of interesting components as on today to cover, and let me just pull that up on the screen. Um, right, so serverless, the term serverless itself is kind of a misnomer in these days, right? Um, there cannot be anything that can exist without a server. There has to be some kind of a server in the background. Before we start with um, the whole session about serverless, and we got pretty decent audience here. A lot of people that I can see joining from different geographical regions. Outstanding. I'll just start a poll here, okay? And you should be able to see the poll on your screen. That will just give me an idea about your knowledge on serverless platforms, okay? And you will have these polls coming on and off during this session. So there you go. I just started the poll. And the question is, have you worked on any serverless modules on cloud platform? Well, it could be AWS, Azure, uh, Google Cloud, or anything, yeah. And let's say even if you're knowledgeable, that's fine. Even if you have got into some kind of discussion with your colleagues or your customers about serverless, that's absolutely fair as well. Okay, wow, we got numbers kicking in, and I'll share these numbers to you in like next 15 seconds. Should be fine. We'll keep the poll open for 15 seconds. We got great participative audience, by the way. It's amazing. Um, Everybody's doing the poll. Okay, so we see here that 20% of the participants here have worked in production. Great, awesome. So I will have some input from you. And for 50%, it is totally new. It's a fair audience. And some of them have been getting their hands dirty, tried in proof of concepts environments. That's amazing. Yeah, that's what the learner's attitude shows. You gotta try things, and that's when you will be knowing about it. Amazing. Okay, so these are the numbers. So I'll just show that to you as well. I hope you can see the results. Okay, serverless. Let's get started with the cream of this subject today, which is serverless. Yeah, like I said, serverless is a misnomer, and it's not me who's saying it. There are several industry experts who have the same opinion, and I'm sure people have worked on it, or you got into a discussion with your colleagues or customers. You might have felt the same thing. Now, serverless is a misnomer in the sense that servers are still used by cloud service providers to execute code for the developers. Now, the reason you have the term less, right? Serverless. Now, this word less is appended is because the developers spend less time on the backend development and they spend more time writing the application code, right? So that's what their cream topic is all about. Developers like to or love to work on the code rather than working on the servers. They don't like to take backups. They don't like to maybe encrypt the whole server. Um, well, there are certain aspects that they are great about, which is writing the code, finding the bugs, fixing them. That's what they like to do, and not maintaining the server. Now, once the code is pushed, the server will automatically scale on demand, backend, right, behind the scenes, and it's all managed, fully managed by your cloud service provider. So it's not that there are no servers, rather, it is that people who are responsible for building an application no longer have to think about servers or just about anything else the application needs to run on those servers. So you don't have to take care about storage, patching, load balancing, security, compliance, and all the whole list goes. It's a pretty big list. Well, what you gotta focus as a developer, just write your code, push it to that serverless component, and it will take care of it. At the end of the day, as a developer, what you're dealing with, sorry, what you're dealing with is the code, right? You don't have to deal with the servers. Of course, as a developer, one would like to handle and deal with the nuances of the code, but not servers, and that is what exactly serverless does for you. The power, the storage, the memory that your code needs is given by the backend serverless infrastructure. So for you as a developer, there is no server. There is no server that you gotta manage, but you just handle and manage your code. Okay. I will be constantly looking at the Q&A panel to see if there are any questions. And as and when I see them, and as and when there's an opportunity to handle or answer them, I will answer it. Okay. Now there's a question here from Harbaksh Singh. It says how to scale Kubernetes cluster with resilience across multi-cloud like master cluster in AWS and backup or active master in Azure GCP. Well, that's a mouthful of a question. And too early to answer. We're just beginning the level 100 class. So let's keep it simple. If I answer this question, there are about 60% who are totally not aware about serverless. So I'll keep it for later discussion at the end of it. Okay, Jatin, your question is upcoming in the next slide. Um, Swarnava, so does that mean that in the serverless cloud there is no scope of work for sysops? Not at all. It's not like that. Even in serverless, there is a scope of sysops because let's say you are building a Kubernetes architecture, you need to, let's say, open the ports on the security groups, right? Take care about the storage and its encryption. The whole concept of DevSecOps then comes into picture. So nobody's losing their jobs. Okay. Yeah, correct, Kolol. Can we run ML in serverless architecture? You can, absolutely. Okay, so interesting questions there. I'll keep moving forward. So what are we gonna do today? There's there you go, special offer. Well, I'll just talk about that in a minute. Um, Introduction to serverless on AWS, Lambda, Gateway, AppSync, Step Functions, Kinesis, Athena, developer tools, ECS, EKS, and finally the Whizlabs surprise offer, which we're gonna talk about at the end of the discussion today. So I wish I could do all the labs for this. I wish I could show you all the points one by one, all of them doing the live demonstrations. However, we got 2 hours, and out of which we have already spent some time, about 12 minutes. So I will not be able to show you all the labs, but we'll try to keep it as much as hands-on as possible. So what I've planned for today is to show you the labs on AWS Lambda and EKS. Again, it's a level 100 class just to give people taste of it so that you understand the functioning of it, understand how it functions, and why would you use a particular serverless service in a particular scenario. So at the end of this discussion, I'm very much confident that you will be able to come up with one of these services when given a situation. So if I ask you a question, hey, which of the services will you use if you just have to use a code, let's say Node.js code, and then you have to run it at, let's say, 6 a.m. in the morning, which one of these will you use, right? So questions like this, you'll be able to answer for sure. Um, Hands-on, we'll do the hands-on for, like I said, Lambda and the Kubernetes services. To start with, of course, to um, yep. So we already did poll for this was quite early, so I will move on to the next one to save some time. Now, like I said, these are the key topics here, and the lab demonstrations will be on point one and the last point there, which is EKS. And today I'm really excited to talk about various serverless options that we have in AWS. And there's a lot to cover um, in terms of these services. And demonstrations is something that I really love. I'm a hands-on guy, a technical person, uh, but there's always a interest of time that we've got to cover agenda. We also got to answer some interesting questions coming up here. Um, so so we'll speak about certain services theoretically, and for other services we'll do hands-on. Yeah. Well, one thing to keep in mind is that this is not the last session, or this is not the first session that WizLab has conducted. WizLabs always wanted to promote technical education through various channels. It could be blogs, articles, training courses, webinars, like these. So don't be disappointed if the particular serverless component is not coming up here in the lab section, because there's a lot coming up in future, and there's a lot coming up from WizLabs for demonstrations, etc. That being said, and without wasting much time, let's just cruise into the topic for today, which is serverless computing. Um, and you already know that serverless is pretty bad name to call it. Serverless is a misnomer. And well, this name just highlights the fact that you as a developer or end user do not have to manage the servers, right? You just have to run your code. So probably this slide will answer some of your questions. Okay, so I've got concerns from few people that the left portion of your slide is often hidden. Please try full screen. Okay. I have two more computers connected to the same session so that I usually do that to check these things to see what you see, yeah? And I don't have any problems with the other two computers on my right hand side. Now, is there any other person from the audience who have issues with, let's say, audio and the video transmission and the slides? Okay.
Actually, hello Anand.
Yep.
Yes, it's all right. Even I have connected another laptop with this session,
Hmm.
and it's all right for me as well. So I think maybe it's a specific case, maybe due to some
Great.
resolution and
Okay.
all.
I
So
understand. Okay.
okay.
Catherine, I suggest that you maybe play around the settings there and click on full screen. So that should probably help you. Okay. Thank you. So with this, moving on to this particular part. Now, I'm sure, not sure, but somehow guess that you all know cloud already. Some part of it, at least from the very basics of it, where you can probably understand what is SaaS, what is PaaS, what is infrastructure as a service. Yeah. Um, so, well, I'll not talk about what IS, PaaS, and SaaS is, but you see where this serverless component is fitting in there, right? It's fitting somewhere between PaaS and SaaS. And what does this mean for you? Oops. Okay. What does it mean for you? It means more about the shared responsibility. How much of responsibility do you have in the serverless component? Well, it's the overall application landscape that provides services to the customer. When I say application landscape, it is the front end and the back end. Now, in this case, the back end is totally handled by your cloud provider. So, when I say backend, specifically what? It could be backups, it could be encryption, it could be providing networking services or the storage, well, everything that you see in the gray section here, gray boxes. Okay. When it comes to that light orangish part, the front end, which is then handled by you, and certain components of your backend as well. And there was a question from another person. Um, SysOps has got no role here. Well, SysOps is absolutely some role. There's not a lot of things that you got to do. At least you got to have, let's say, the VPC created in case it's a Kubernetes service, right? Unmanaged Kubernetes service. Then you need to have um, the networks created, the routings created, the security groups created, etc. Well, the developer has his own things to do and things to work on, right? Okay. Bash is backend as a service. So people have come up with their own terminologies, apart from IaaS, SaaS, and PaaS, there are others as well. Here in this case, you see serverless, which is function as a service or backend as a service. Um, Active Directory, they call it as identity as a service, security as a service, communication as a service. There's a lot of terminologies that have been coined these days, but primarily, right? Primarily, it's all IaaS, PaaS, and SaaS. Yeah. Okay. So technically, in the public infrastructure as a service, the first block there, the end user is not physically managing the servers, right? That's up to, let's say, Amazon or Microsoft in the world. So, but the so-called serverless computing takes that idea and it takes that step further and executes code that developers write using just the precise amount of computing resources that's required to complete the tasks. Nothing more, nothing less. So if some of your developers or if the people who are not developers probably have been shoulder surfing the developer's laptop, they have the Visual Studio Code opened up and they click on that play button on the top to build it, to compile it. It takes a certain amount of memory and CPU, right? Maybe your laptop has 16 gigs of memory and the execution just took maybe on the higher upper side 4 gigs. Yeah, upper side, I'm saying 4 gigs just to execute and build the code. Okay, what was your investment? Your investment was on 16 gigs, not on 4 gigs. With serverless, what you're saying is that when I execute and compile it, I will be using just that precise amount of computing resources, which is 4 gigs in this example. Yeah. Plus, I don't have to keep that 16 gigs always in my laptop bag all the time. Yeah. Or on that server. I will use that 4 gigs and then give it back to Amazon, and you will be charged just for that duration. Isn't that great? So let's say when a predefined event occurs and that will trigger some kind of a code, the serverless platform will execute the code. The end user, the developer, does not need to tell the serverless provider how many times these events will happen or how many functions will occur. Customers will pay a fraction of a penny every time a function is executed. It's better to use, in fact, some people say that it's better to use the term event driven computing, and that's a better term as compared to FAS or BAS or serverless. When it comes to serverless, you say event driven computing. That means when an event occurs, you pay for it. When an event occurs, the computing resources are allocated to your code. And when the execution is complete, the resources go back to AWS or Azure or Google, whoever. Yeah. So serverless computing is an architecture. I'm just summarizing the whole thing now, where we are saying that the code execution is fully managed by a cloud provider instead of the traditional method of developing applications and deploying them on servers. And it means developers do not have to worry about several things like managing, provisioning, maintaining the servers. Just focus on deploying the code. And previously, the developer would have to define a lot of things like storage, the database capacity, even before deploying. And that actually slows down the whole process in today's agile environment. So naturally, there are servers in the backend, but their provisioning and maintenance are entirely taken care of the provider, and the provider charges only for the compute time used at the execution time rather than a flat monthly fee for maintaining a physical or a virtual machine. Now, that's being repeatedly said. And when things are repeatedly said, things become clearer. Things go and drill down into your mind faster. You'll be able to retain these concepts. So that's where I'm trying to put the same thing in different words with different pictures so that you retain it for a longer amount of time and not to kill the time. Yeah. AWS Lambda. Let's talk about why we need AWS Lambda. If I say what AWS Lambda is, it will be like repeating what I said about serverless computing. AWS Lambda is serverless and it just does exactly that, executing the code when required. Yeah? Now, it is a computational service that will provide you the compute services for executing your code. Serverless is a generic term. AWS Lambda is AWS proprietary. Yeah, needless to say that. Yeah, AWS is right in front of it. So now, certain questions. Let's start bottom up. Yeah, instead of going to the theory and then da 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 da, I will ask: can I host a web application inside AWS Lambda? So you're a developer and you got a code and everything, and now you want to host your web application inside AWS Lambda. Can you do that? Your answer can be yes. Your answer can be no. Your answer can be I don't know. I'm here to learn. Yeah. All right. I've got two answers. Okay. Four now. Okay. Five now. I'll wait for one more answer and then awesome. Okay. Good. The result is that it's a mixed set of audience here. Some of us say no, some of them say yes. Okay, I'll ask this question one more time later on once I'm done with the discussion about AWS Lambda. Okay, so I got to step back. The people who are probably incorrectly answering the questions, and that's fine. Incorrectly answering the question is fine. We are all here to learn. So one thing I want to tell you is that AWS Lambda is purely for executing your background tasks. What is a background task? A background task is usually some kind of a code. If you recall your traditional environment, you had the scheduled tasks, right? Scheduled tasks which used to run on a server at a particular time of the day, right? AWS Lambda is just a replacement for it. In fact, mm, this is you can just say scheduled tasks on steroids. Yeah, it has a lot of capabilities, not a lot of capabilities more than scheduled tasks. So if you got a code and you want to execute it at a particular time or based on an event, then you use AWS Lambda. You cannot use AWS Lambda for deploying web applications. And that means that you cannot take your code and host it inside AWS Lambda. For that purpose, you got something else. For that purpose, let's say you got EC2s for your dynamic applications, Elastic Beanstalk for dynamic applications. You got what else? S3 bucket, maybe for static applications, you can. That's okay. But simple index.html files. In production environments, I've used or have seen the S3 buckets being used primarily for storing pictures, images, videos, files, etc., but not for hosting a web application. Yeah, it's okay if you're doing a static page, go for it, but not for a dynamic page. Okay, so you got the answer. You can go for an EC2 or a Beanstalk or a Kubernetes cluster if you want to host a web application, but Lambda will not do that for you. Okay, you can just upload your code to what Lambda, and it just gets executed. When does it get executed? It gets executed at a particular time. That's option number one. Second is based on an event. Okay, based on an event. So if you're looking for deploying web applications, you got others like EC2s or Beanstalks. You can do it there, but Lambda is purely for executing your code. So now, if I ask you the same question, can I host my web application there? You'll answer no. But how do you use this service? So let's go take a look at this in action. Okay. Um, but before that, I'll just give you a scenario. Okay. Um, there was a client actually located in California. This guy was making what IoT devices. Okay. Um, have you heard of these devices called Raspberry Pis and other IoT devices? Yeah. Node MCU, ESP3866 chipsets, smaller chipsets. Yeah. So what he did that is he used a small chipset and wrote a program in it, and also attached a very small 5 megapixel camera to it, and said, "Hey, take pictures." Right. So that program was constantly taking the pictures. Great. Now, um, he put that in the kindergarten just to see how his kid is behaving. Behaving in the sense what a kid will do. For 3 years old, he will cry or smile or play around. Maybe if he's not happy, then he will go and sleep or something. Well, these are the behaviors, right? So he wanted to look around his kid's action while he's working in office and his kid is out there. So he gave that device to the kindergarten fellows. Great, great. So that device was connected to the wireless. It had its own LTE chips. The 4G chip was there, so there was no need to use the kindergarten's Wi-Fi. Great. So why are we talking about this story? Talking about Lambda functions here. I'll tell you in a minute. So the pictures were taken every couple of minutes. So considering the processing power of the ESP866 processor, it used to take about 11 pictures a minute, right? 11 pictures a minute. Um, and the camera was about 5 megapixel. So considering that, every picture size was about 2.5 MB. So 2.5 MB multiplied by 11 pictures a minute, and how many you will have in 8 hours? Several. And all of that is going to, let's say, AWS S3 bucket. You have the picture right in front of you, the source bucket. Let's say it's all going into source bucket. 2.5 MB each is like massive. Not for one picture, but when you think about 0.5 multiplied by 11 multiplied by 60 multiplied by 8. That's pretty big, right? It's all going into the source bucket. And he also built a small web application inside a static web application on his whatever S3 bucket, or maybe in an EC2 instance, doesn't matter. But a web application was there where he could log in and look at all those pictures, filter them, do whatever magic he wants to do with those pictures. Yeah. Okay. So, but then he realized that he is paying a lot of bill to Amazon. So he used a Lambda function to compress the pictures in that source bucket and then automatically move them to the target bucket. After certain days, like 1 day or 2 day, the source bucket was churned using the lifecycle policies, and the pictures were deleted in first out order. All the compressed pictures, well, he used a lossless compression to compress the picture, so the picture should not lose the quality, but it must be compressed as well. Okay. um, so that's the beauty of Lambda functions. He's using Lambda functions to look at the source bucket every couple of minutes, and every time a file gets uploaded there, he just compresses it and puts that in a target bucket. The web application on the EC2 instance will be looking at the target bucket and not the source bucket. Okay, so this is just a use case. So as soon as a photograph gets uploaded from that ESP3266 chipset, the Lambda function detects it, the code inside it gets triggered, and thereafter it picks up the file and compresses it, loads into another bucket, use a lifecycle policy on the source bucket to remove the files after a certain number of days to save the costs. Okay, so that being said, and this is an event based trigger, right? Based on an event. And what is the event? The event is the file gets uploaded to the source bucket is an event. The code inside the Lambda function, so just recollected some of the important points. The code inside the Lambda function cannot run forever, right? It cannot run forever. It needs to, there's a timeout value which I cannot remember at this time. There's a timeout value after which the Lambda function will automatically stop. Okay, so Ramnik added value here saying 900 seconds. Okay, so after 15 minutes, it's gonna stop. Um, and you will be charged every time it runs, and you can just host that code inside um, inside the Lambda function. There is no cost of creating a Lambda function and keeping the code there. All right, so I want to show you how this whole thing works inside the AWS console. So I'll just escape from here. um, all right, so I've got something running here. I'll go to what, Lambda. Da, 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 da. And in parallel, I'll also open S3 bucket. I'll be doing few things in parallel, okay? So um, don't miss out the action. Okay, my Lambda function is in Oregon. Okay, I'll just keep it as Oregon, leave it like that. And to save some time, I've already created few buckets here, okay, for this demonstration purposes, because um, there's a bucket here, source bucket, and there's a destination bucket, let's say prod bucket, or the vice versa. Or there's a resized one as well. So if I click on it, I already have a picture here, which is sunset.png. The size of this is 314 KB, which is not big, but let's see how Lambda functions can compress it and move it to this particular folder. So I will get rid of this guy from here. Delete, delete. Okay, that's gone. So the source bucket resized is empty, whereas inside source bucket images, there is a file, which is 314 KB. So I'll go to Lambda functions, and in the Oregon region, I'll create a function. And both of my buckets are in Oregon region, if you notice. So if you want to do the similar lab, then you need to make sure that these buckets in the same region as the Lambda function. Okay, so I'll go here and click on create a function. Now there are multiple options that you get. You can either start writing your code from the scratch, or use a blueprint, or use a whole lot of templates, some kind of a repository that's already available. There are a lot of these templates available. You see on the top here, up to 49 pages. So depending on what your organization wants, you may pick and choose a particular template and start modifying there. All right, so go back to author from scratch, and I will give it a name. Okay, so let's just call it compressor. Okay, compressor. And look at the runtime programming platforms that Lambda supports as on today. There are a lot of these, right? When Lambda initially started, it was just supporting Python 2.7 and Node.js, some of the older versions, I believe, Ruby as well, older versions. But they have really picked this up and made this corporate production ready. So if you are comfortable with Node.js, you can use it. Comfortable with Python, Ruby on Rails, anything, you can just go ahead and explore this. Yeah, this the options are just 2 minutes. So I'll select Python, let's say 3.7. Okay, the next option is execution role. This is also very important. Now we will need a role when we are um, communicating or making some transactions between two or more services. In this case, the two services are Azure AWS Functions, which is the Lambda, and the other one is S3 bucket, right? So I already have a role here. I will go ahead and pick up the Lambda execution role. So if you want to see what this role is actually doing, I'll just show that to you. Services IAM. Okay, and then go to roles. And then if I say Lambda here, Lambda execution role. Okay, so this role has full access on S3 bucket, right? Lambda execution role has full access to the S3 bucket, and that's when it needs to upload or compress files, it will be able to easily do that. That role is already created. Okay, so I'll click on create a function. Okay, so that's ready. Now you need to tell this guy whether it needs to use an S3 bucket or what kind of a service do you want to actually use here. Okay, so the first step here is to go ahead and add a trigger. Okay, which is on the left hand side, and then my trigger here is the S3. As you see, there are a lot of these triggers available. Any kind of service, Azure specific and not Azure specific, both of them are here. So I'll say S3 and then select my source bucket, which is source bucket images. Okay, and when do you want to take an action? Inside the S3 bucket, you will have several HTTP operations like put, get, post operations will be happening, delete operations will be happening. Let's just select all events, and then I'll say enable trigger, and I acknowledge this and click on add. So that's done. Okay, there's an error. Okay, configuration overlap. Configuration in the same bucket cannot share a common event type. Um, the problem here is, give me 1 second, I'll fix it. The problem is if I go back to Azure Functions, there's another function here that's doing some other operations on the same bucket. So I have to get rid of this. Okay, let's give it a try. S3 again. It's source bucket images. Okay, add share common event type. Mhm. Okay, so I think what I have to do is not use these buckets at all. So I'll quickly uh, create another one called as source images. Oregon is okay. Just leave it as next and next. Let's go by the default options. Uh, yeah. Okay, so that's created. I'll try one more time. One thing is that when you're doing demonstrations, you should always pray the demo gods. The demo gods are not happy, they will not let you do the demo. Okay, source images. Okay, all right, I acknowledge that. Okay, today my demo guard is happy so far. Let's see. So it added a trigger there. Okay, so I'm saying that this is the trigger. Trigger is when something happens to my S3 bucket, there needs to be some kind of an action taken. We have not defined that action yet. Okay, so that action is now defined in a separate place. So I'll scroll down to the bottom, um, and then right here, click on compressor. Okay, and here it will show the code. So this code will execute it. This code will get executed when some kind of an action happens to S3. But you don't want this to be executed, right? We want our own compressor algorithm to run. So let's say actions, and I can either write my own code here or upload a zip file. Um, well, no, I have it inside my S3 file. Okay, so there is a code already available. Let me pick up where it is. Just a moment. Not take much of your time. Another 10 seconds. Okay. Okay, got it. Done. So I'll just go here and copy and paste this. So my code is available here. So in fact, I'm using uh, certain lab demonstrations. The Python code is already available here. So I'll click on save to see what happens now. There you go. It added certain more attributes here. Okay. So what do I do next? There are two things that I've defined. One is the source. So when an action happens on S3 bucket, what should happen? The function code that I just uploaded here. Now, what we have to do is go to the basic settings, somewhere in the bottom, function code, environment, basic settings right here. So I'm using a Python 3.7, using about 128 MB to execute this code, and the timeout is defined as 3 seconds by default. You can go ahead and edit this and give it some name. Let's give some any description, doesn't matter. I said compressing an image, doesn't matter what you're typing here. And then what's important is a handler, which is not Lambda function dot handler, but it is a different Lambda function which is already defined in the code. Say create thumbnail dot handler. This is the one responsible to compress it. And another point is the memory. How much of memory do you want to allocate to this code? Since this is a very small piece of code that we're executing, the default 128 MB is enough. The timeout value can be defined as well. We can leave the execution role as the same thing because this has full permissions on the S3 bucket. I'll click on save. Okay, so that's saved. Now it's time to test our Lambda function. Okay, so I'll click on test on the top right hand side. We don't have any event to test at this time, so we have to create one. All right, click on test to create a new event. Under the event template, right? What do you want to do? Mm, well, I want to upload to the new bucket, right? So the event template will be AWS S3 put. The upload is a put operation. So I'll click on put and the event name, I'll just call it as, let's say, upload my files or whatever. So here's the code that will be used to upload. All right. So this is a sample template that is displayed. So the event data sent to the Lambda function when it is triggered by an upload into S3. So you need to edit the bucket name here. Okay, this is a default template. You need to edit the bucket name. For example, here the bucket name is example hyphen bucket, but my bucket name is different, right? My bucket name is source whatever images, source or hyphen images. So I'll go ahead and um, replace it. Okay, and there's another place also which is here. Okay, so I've replaced in both the places. There's one more thing that you need to specify here is the object key. Now here you're telling which file you need to upload, exactly the file name. Okay, so you need to replace the test hyphen key with the file name. So I'll go back to my S3 and there is no file here is inside it. So I have to upload that file. Click on upload. I'll see if I can drag and drop the files. Um, so let's okay. So I've got a nice picture here. I'm just uploading. It's a sunset picture. Click on next, and I'll just grant public read access, although it's not required, but that's fine. Click on next, next, and go through the standard procedure. Okay, so the file is uploaded, almost there. Great. And my file name is sunset. So I will copy that name, go back to Lambda function and paste it here. Okay, that's done. So these are the only three things that we have to do inside this code. One is to modify the source bucket name where the data is coming from and the file name. I'll click on create. So on the top, you see we have a new test event, which is upload. We just created it. You can click on test now. Let's see what happens. We got an error, and most probably the error will say that yeah, it is not found. It's only because the bucket does not exist. The source, the destination bucket does not exist. So let's go and create it with this name. What was it? Create a bucket hyphen what? Resized. Resized in the same place. It's okay. Next, next. Okay. Leave these values default, and let's try one more time. Okay, test again. Yeah. Okay. We're bumping into a lot of issues today, but let's see if I can fix quickly. Okay. Name is also same, and the file name is this. Okay, here. Okay. Um, Jatin, the destination gets automatically added from the code um, because it is hard coded there, which says that if the source bucket name is source hyphen images, then the target will be source hyphen images hyphen resized over there, and that's automatic basically. Mm. So we have used the same name here as well. The typo has been carried forward in all other places. That's okay. Uh, so we got test event S3. We create a new event. S3 AWS S3 put. And here, This is where the bucket name must be changed. I think the regions are same. Oregon. Oregon is US West too. Um, Try one more time, and then if it doesn't work, we'll continue. And if you got time in the end, we'll fix this. Okay, so that's that. That's that. That's that. All right. Okay, this time it got succeeded. Okay, there was some minor things. It's the same thing that I did. Just exactly the same thing that I did. It just got succeeded this time. So what I will do is go back to the second resized bucket. See, this is there. I really cannot tell you here what went wrong, even as a technical person that you are watching here. It's the exact same thing. So once the session is over, I gotta look at the difference between upload and new upload here. But the current upload thing worked. I just did the same thing. Yeah, just did the exact same thing. So there's some miracle. Anyways, it's fine. Um, so with the help of this uh, function, we are able to do what? You see, this is the resized bucket. Okay, this is the resized bucket. And if you look at this one, this is the original bucket. The original bucket file size is 314 KB, whereas the resized file is 10 KB. Now, every time some kind of a file appears in this with that name, it will compress it and put it here. Now, this really doesn't seem production ready. The code is not production ready. Why I'm saying this is because if you look at this code, it is looking at a particular file. There must be some algorithm which looks at just say, let's any file that gets uploaded. So you need to make it more intelligent. But the objective was to show you the power of Lambda functions where I do not have to execute any code manually, but it will be triggering based on a particular event. Okay. So we spent some about 8 to 10 minutes troubleshooting this one, and in the end, it was solved by using the same set of steps. Just did the same thing, and it worked somehow. But I'm not sure because if I would have done something, then um, I'm following the same set of steps that were done earlier. Anyways, I hope you got the objective of Lambda functions that it could be used as a serverless function. It's an event-based trigger, and it can be also scheduled based on a particular time. Any questions you have on the Lambda functions here? Okay, thank you. Okay, that helps. Sure, Catherine. The Lambda functions, as you saw, that we just uploaded a code there, and it got executed based on the event. And the event was that we uploaded a file to S3 bucket, and it has compressed it. And if you look at the file size, the original file size, it is 314 KB. And after the Lambda function got executed, after the Lambda function got executed based on the compression behavior, it is 10.2 KB. Is that okay? And thank you. Thanks, Harbugs, for your inputs there. Right. So you need to throttle that. So if there's a lot of traffic coming in and you need to do a lot of transactions per second, then you need to go and throttle that, increase the memory, increase the number of transactions by doing that. Yeah. So there's a throttling option here. Okay, considering the time that we have spent on this one, Varun, I'll definitely show you the code once we are finished with that because there's a lot of things in the agenda. Um, the next topic here, which one is it? It's a PowerPoint. F5. Okay, so this is the Lambda, and the next one is the API gateway. Thank you all for your patience while I've been troubleshooting the Lambda functions, and also thank you for giving the inputs. Well, it really makes us think why certain things go wrong with no reason. But there's one good reason given by Harbaksh is there on the screen. And what he was saying is that sometimes there are cached entries, sometimes there are stale entries, sometimes there are 2-minute transactions happening. There could be large API calls which have the preference, right? So sometimes you have to wait for like 15, 20 minutes to give way to our API queries. That's fair. Okay. API gateways. Let's start with this with a use case directly, okay? Instead of going through the theory. Now, what I have here is self-explanatory, isn't it? Two devices which are talking to your web application. This is a very common e-commerce application. So if you fire the home page, yeah, as you see, there are several pages there. There's slash home, slash product, slash my cart, where you can get the items from your cart and add items to your cart as well. So this is a very common application. So if you fire the home page, it gives you a static HTML so you can search for the products. But if you need to add items to your cart or get items from your cart, you need to log in, right? Without logging in, you cannot add items to the cart or add items to your inventory. Usually, that inventory is a JSON file. And these clients on the left hand side can be different kinds of devices, mobile device or desktops, etc. Now, going to the next part here, we're making it more intelligent where we are saying that you need some kind of an authentication. Sometimes you do not need authentication. When do you not need authentication? When you're going to a home page of a particular company's product, let's say slash home or slash products. But when you need to retrieve items from your cart or add new products, right? You need authorization and, of course, authentication as well. So, getting items to shopping cart, we want to ensure that the user is logged in. Another place where further authorization is required is when new products must be added to the entire portfolio. For example, an admin. So, is the signed user a valid admin? So, some kind of a validation must be done. Another scenario, right? Very common use case. In the same web application, you also want to add another layer of security by adding HTTPS transaction. So, an SSL certificate must be added. Also, the certificate must be renewed as per compliance based on number of days. So, the certificate rotation is a standard practice. So, you see various components that we need, the three little boxes. You need the SSL certificate, security, you need authentication, you need authorization to be validated. Apart from that, business logic. In addition to the business logic, you need all of these components. The business logic is like home, products, your items in the cart, etc. So would it not be great to have these three items separated? Like you got SSL certificate, authentication, and authorization. Why don't we move it away from the business logic so that it could be handled separately? So that's where the API gateway comes into picture. API gateway is that separate entity. So API gateway is an entry point for your APIs for your web application. So all the requests from all kinds of clients will go to the API gateway. So this ensures that the users are authenticated before they have a connection. So let's say they are going to a cart. Um, Whenever they are going to a cart to add the products, um, to maybe read the items from their cart, they need to be authenticated. And that is done by the API gateway. What is API gateway then? API gateway is acting as an entry point, a guard, a wall, a doorway for any requests that are coming to your application. So this is handling your authentication, authorization, SSL termination certificate as well, and also protecting you from any malicious actors using DDoS protection and throttling. In certain scenarios, you will split the web application into multiple microservices, let's say. On the right hand side, you got two microservices, microservice 1 and microservice 2. The microservice 1 is handling the homepage, products, my carts, whereas let's say if an admin needs to log in to add new products to the portfolio, well, then you will use the microservice 2. Okay. Um, this is more of a scalability scenario as well. So even if we scale these multiple microservices, right? You got microservice 1, 2, and let's say it grows up to 3, 4, 10. You can continue to use the same API gateway. So here, anything related to products is going to one microservice, whereas API requests related to product addition or deletion or adding, modifying the admin job, basically, it's all going to second microservice. So API gateway will decide which path the route must go, which path the API request must go to. Yeah. To summarize this, it's a reverse proxy which works as an entry point for all your APIs. It has different features like authentication, SSL termination, routing, load balancing, monitoring, the billing aspects. Basically, one stop shop for your API entries to your application, a front door for your applications to access your data, access your business logic, or functionality from your backend services. So, the microservices that we have, the different kinds of backends that are supported are, let's say, containers, of course. To build a modern application, you need to have support for containers. Serverless workloads, EC2 instances, of course. Yeah, it can also connect to your S3 buckets. These are all can be your backends to your API gateway. API gateway can handle hundreds of tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls. It's pretty robust service from Amazon. Okay, I'm still looking at the Q&A section to see if there's something. Uh, and since there's nothing, I'll continue there. AWS AppSync. Before we start with AppSync, I need to introduce you to a new uh, query platform, which is called as GraphQL. GraphQL. So I'll go to graphql.org. Um, okay, so that just Googled for it. Okay, anyways. You see, GraphQL, it's a query language for your API. So if you'd like to query certain services, sorry. So if you'd like to query certain services um, within your AWS platform with the help of a query language, you would use GraphQL because it's pretty predominant. It's used in multiple applications. It uses JSON as a standard format for querying purposes. It's a new language that's actually budding up with several applications and several developers. And hence, Amazon needs to come up, or Amazon has already come up with a new service which is called as AWS AppSync. So what does that do? It will help you run GraphQL APIs via a unified query language. So where is my presentation? Here. So on the top right hand side, in the middle somewhere, you see this GraphQL microservices. Okay, you can run REST microservices and any other private microservices as well with the help of AppSync. So under the hood, AWS AppSync is running a GraphQL, a proxy service, a GraphQL proxy service that will receive all the GraphQL requests. So your ingestion point for your GraphQL queries is AWS AppSync. Your code inside Lambda or any other service need not be aware of the GraphQL service at all. But if the third party application is running that query on GraphQL, then AWS AppSync will understand that and translate it into what AWS Lambda runs on. So GraphQL proxy, you can consider AppSync as a GraphQL proxy that just sends and receives and parses all those requests before forwarding it to your AWS services. Okay, what's next? Step functions. So AWS Step Functions is there to orchestrate multiple functions. If you're using a single function, then it is Lambda function. But let's say you want to use a workflow. Let's say there's a function called as A that triggers, and if that A triggers successfully, then function B triggers. And if that B function does not trigger successfully, then C triggers. What are you creating? You are creating something like a workflow, right? So step functions is quite convenient in handling automatic items in the workflow, trigger individual entities, tracking each workflow, and ensure that these functions are executed in a step order or stepwise. Initially, when you are creating a step function, it takes a lot of effort, but once it is done, um, it just runs hands free. So there's not much an effort that you got to do. So as you see in the picture here, the photograph gets uploaded to the S3 bucket, and then the step functions gets executed. Step functions is again an amalgamation of multiple Lambda functions which execute or which gets executed in a particular order. Okay, so then there is Kinesis. Swarna, I got your question. I will park your question for AppSync the end of the discussion once we're done with the whole thing. I'm afraid that we may be losing time. So I've also made notes uh, about the question. Okay, I've got two questions on my notes right now. One is about AppSync from you, another one from Harbaksh, which he asked initially about multi-cloud ability, right, for Kubernetes. So I parked that. Moving on to AWS Kinesis. We all use this wonderful application called as Netflix, right? So let's understand this with a Netflix scenario. You know what Netflix is? So Netflix is like the world's largest internet television network. So more than 100 million members, 125 million hours of TV shows, movies every day. There's series, documentaries, films. People who or the members of Netflix can watch as much as they want, anytime, anywhere, on nearly any device that is connected to the internet, of course. So you can imagine the amount of processing power it needs for processing that, hosting it, the storage space, streaming it, right? Massive. So what it needs, what applications like Netflix will need is robust infrastructure that Amazon provides. So in this case, this is provided by AWS Kinesis, right? You can think about maybe 100,000 servers running in parallel. It's kind of a complex infrastructure for them. So when you want to collect the real-time information, how many people are watching the videos, right? At a particular time. How many videos have been watched? Which of these videos are on the top? So that kind of analysis needs to be done, more of an analytics kind of area, yeah? So Netflix uses Amazon Web Services, of course, for various areas like computing, storage, database, analytics, video transcoding, and hundreds of other functions. Yeah, and this hundreds of services has let it uh, make it itself in itself a complex environment. When you think about monitoring, optimizing network, improving customer experience with various services, reducing the cost at the same time, being efficient on the competitive scale, it's paramount that the Netflix uses a robust infrastructure. And here, the Kinesis specifically will let them stream the web applications or the videos, audio content at the same time, rendering the applications to different kinds of devices. Could be mobile client, thin clients, servers, wherever the data needs to go. Kinesis is required here to provide a real-time experience in terms of when they click on it, let's say the audio and video should render at the same time. Okay. So what is Kinesis used for? Streaming purposes. Okay. When it comes to data streaming, wherever you think about video streaming, you would be using Kinesis. Yeah. Okay. Next one is Athena. What we do not have today in the S3 bucket world is the querying capability. Let's say you got lots of data inside your S3 bucket and you want to query the data. How many of these buckets have been used for what period of time? Basically, the insights of it. What organizations usually used to do is extract all the data from S3 bucket and put it inside a database for querying purposes. But with Athena, what you're doing is that you are able to query the S3 directly with a simple SQL based query language. AWS Athena is part of the AWS big data stack. So when you think about big data, AWS Athena is one of those components in the AWS spectrum of services. So what is it allowing you to do? Athena is allowing you to query the files that are stored inside the S3 bucket without loading that S3 bucket metadata into a database. And you can still run the SQL based queries for the object stored inside the S3. To use this, you simply define a table that points to your S3 data and fire all your S3 queries or fire all your SQL queries to it. So it's a simple way of running all those queries on your S3 bucket. That's right, you can use select queries, the SQL based queries using Athena. You're right. There's an array of developer tools that AWS has in their portfolio. There's a lot of them. When it comes to the DevOps world, it has really created a disruptive business for several organizations. So automation is the key. So you got code pipeline, which will let you quickly build and test and deploy the code. Then there is code build, which will let you compile, run, test your application code, and leave with a deployable package. And there is code deploy that will help you um, automatically deploy the code to, let's say, an EC2 instance. Could be on premise as well. So that will increase the velocity that your organization can deliver additional functionality to your business. There's another one called as AWS Code Star on the top, the Code Star. This Code Star will help you facilitate the development, build, and deployment of applications on AWS services and instances. So basically, it's a one-stop shop of which will help you manage the full life cycle in one place. And there are a lot of microservices. AWS Lambda, we just um, learned about that. There is EC2 container services, other platform as services like Beanstalk, X-Ray, CloudTrail, Config. So these are all the services that one as a developer would need to properly manage the code in a pipeline. These are categorized as software development and continuous delivery tool chain. Then the infrastructure as a code, which is handled by AWS CloudFormation and OpsWorks, and the monitoring component. A usual day of a DevOps practitioner or a DevOps engineer, let's say, will be about maintaining these components and at least having an understanding of these components if working on AWS DevOps. Okay, so there's a small poll here. Uh, I just started the poll. Okay. Okay. Thanks for your time, guys, for the polls. Interesting. I'll show the results to you. We got good percentage of people, almost 50% were beginners, 13% not familiar. So that brings us to 60, almost 60% not familiar, 33% intermediate, and 5% advanced. It's okay. So let's start with the the story of all containers. Okay, the people who are familiar with containers already know what this picture is talking about, isn't it? So traditionally, we used to deploy infrastructure on a virtual machine. On the left hand side, you got virtual machines, and on the right hand side, you got containers. And the objective of next 5 minutes is to understand the difference between deploying a web application on containers versus virtual machines. Historically, when you had to deploy a web application, you will deploy it on a VM. AWS, Azure, Google Cloud, on-premise, wherever. You will have a virtual machine, probably VMware or Hyper-V. And the whole concept of virtual machines, the VMs, were born to design or to be running on a physical hardware, right? So there's a physical hardware underneath the virtual machine. And on top of the virtual machine, you got the operating system um, that interacts with the hypervisor. So on this little box that you see on the left hand side, you see the infrastructure layer. That is a physical layer, right? The physical layer where you're buying your racks, switches, um, servers, etc. And on top of it, you have, let's say, type 1 hypervisor, where you have the host operating system. Just consider it as a Windows operating system or Linux, doesn't matter. And then on top of it, you install the hypervisor. Let's say VMware Workstation or Oracle VirtualBox, or in production grade environments, you are hosting it on VMware ESX or Hyper-V. Now, once that is ready, now these three layers are ready, you will then start to host guest operating system. Now, these colorful boxes that you see from left to right, green, yellow, and pinkish. So these are, let's say, guest operating systems. Let's say they're all Linux, or maybe two are Linux and there's one Windows operating system, right? Now, based on the application, you will have the binaries installed. So let's say the application one needs .NET 3.5. So you'll have .NET 3.5 installed as a binary. The second one needs, let's say, .NET 4 or something. And the last one needs Python 2.7, right? And then you have a Python application 3 running on top of it. So that's good. This has always worked for us for years. But this approach again has several drawbacks. And the drawback is that every virtual machine has its own separate operating system. It has its own separate operating system image, its own memory, its own storage footprint. So the issue adds up to the complexity in all stages of the software development lifecycle, from development to test to prod to disaster recovery. Plus, you are not optimally using the resources because the application may be just needing, let's say, 3 gigs of memory. It's a lot, but let's say it has 3 gigs of memory. But to the guest operating system, you have allocated 16 gigs of memory. So your remaining 13 gigs is invested and lying waste. In containers, in today's world, the whole operating system virtualization, although has grown a lot of popularity in the last decade, so that you can run the software wherever you want on any server, the containers has taken popularity from let's say last couple of years. Although it's not a new technology, it's been there ever since Linux came into the picture, right? Ever since Linux was created, it's there, but underutilized. But now we understand the value of um, hardware and various other things. We have started to optimally use the feature sets inside the operating system, and containers is one part of it. Linux operating system already had containers. So containers sit on top of, it could be a physical server or a virtual server. It could be Linux or Windows. It could be cloud or non-cloud. Containers can be anywhere. So as you see on the picture, the containers are sitting on top of the host operating system. So you got the infrastructure component, the last layer, right? It could be physical or virtual. And then you got the host operating system. And then you have the containers. Then you have the binaries. So what is happening with this? With this, you are reducing management overhead. A lot of management overhead has been going out because you can optimally use the resources in terms of, let's say, CPU, memory, or giving back the resources to the system once the container is, let's say, terminated, or we don't need to use the containers anymore. If the application one dies, the resources go back to the infrastructure. In case of virtualization, if the application one dies, the resources are still being used by the guest OS, right? It's not giving it back to the infrastructure. What's allocated is allocated. In case of containers, it comes back. And the containers can be spin up and down and terminated very quickly, just goes up and down very quickly because it is not dependent on the host operating system. So if you restart an operating system on the left hand side in the virtual machine case, the application also get restarted. In case of applications 1, 2, and 3 on the container side, if you restart an application, it's just the application that gets restarted and not the whole operating system. So it's pretty quick in a way to bring up applications and production grade applications. And it is also said that when you do Google search, right, when you just go to google.com and hit your search thing, it spins up a couple of containers in the backend for you. And once you're done with the Google search, you got the search things on your screen, the containers get terminated because you do not need that processing power anymore. And of course, the results are all stored in a separate NoSQL database somewhere. But that's the power of containers, that it gives you resources like memory and CPU runtime immediately. And then when it is not required, it just goes back to the system. Okay. So that being said, what are containers? Containers are some kind of an entity that are running your web applications on runtime. They do not need a whole lot of resources. They do not demand a lot of memory and CPU like what virtual machines used to do. They are isolated. They are lightweight in terms of running an application. Inside that application image, you will just have the application binaries and not the entire operating system, and that makes it lightweight. So as compared to virtual machine architecture, the application on the virtual machine architecture needs an entire operating system to run, where in the container it does not need an operating system to run. It just needs a very basic components of what operating system consists of, very basic binaries of what an application needs. Okay, is this clear? I hope it's clear. Any questions? Srikanth, is it clear now? Okay, container security. We did not talk about container security at all. So we have to then talk about the keys and secrets. We'll refer to it later on. Any questions on this one, please? Okay, so no questions. Let's go on to the next topic here, the need for orchestrator. So there's a new terminology. Um, okay, there's a new terminology here called as orchestrators. There's a whole lot of buzzwords today in this world, talking about buzzwords like blockchain, bitcoins, and a lot of other fancy words. And orchestrator is another buzzword. So let's jump into the concepts to get that clear. Um, we spoke about containers earlier, right? And how do you create containers? Well, Docker is one of the most popular um, binary or executable sitting on your computer that will help you create a container. It doesn't sit on your computer by default. You have to install it. We'll take a look at that later. But uh, let's say you got Docker images, say application 1 and application 2. So let me just draw this. It will be easier to picturize it. So let's say you got this one. This is app 1 and this is app 2. Yeah. So that's app 1 and 2. Okay. So these are images. And these images are sitting inside something called as an image repository. Image repository. Just don't like this color better. They are sitting inside the image repository. These application 1 and application 2 are built and they are inside the image repository. So you as a developer has made these two applications. This image repository can be in Amazon, can be in Docker, can be in Azure, wherever. Now this application needs to run, right? It needs some kind of processing power. What does it need? Some kind of a processing power which is given by an EC2 instance, let's say. Okay, so let's say I am creating this EC2 instance. Um, it could be anything, okay? It could be EC2 instance or it could be on-premise infrastructure or whatever. All right. So this application that is built needs to run and it cannot run by itself. And hence we created that EC2 instance in Amazon. So to bring your applications to life, you are moving them. Let's say I'll just move them from here. You just move them from the application repository all the way to the EC2 instance, right? You're giving them life. So they start running in the form of containers. So what you have done by moving it, you are giving your Docker image a life by providing computers via the EC2 instance. Now your apps are running inside a container. Let's say for availability purposes, you spin up another EC2 instance, okay? And you do the same thing. So what you'll do is, for availability purposes, you copied and maybe created another one. And these are too big, so can I make it smaller? Yeah, okay, good. So for availability purposes, you created another one in a different zone, right? And maybe another one in a different zone because now the auto scaling happened. There's a lot of load coming up on the servers, a lot of load there. So now we have three of those EC2 instances running your containers. Great, isn't it? Um, and we got auto scaling running in our environment because it's ideal to keep your web applications in a scaled design, right? So that your instances will spin up when there is certain load and they get terminated when there is lesser load. And it's also important to, well, what I will do is I'll get rid of this. We don't need this image repository anymore. Now it's also important to maybe hang your EC2 instances with a load balancer, right? Let's say ELB, let's call it as ELB. So we'll connect this guy, and this guy. Okay. So you would hang all these EC2 instances together with a masterpiece called as Elastic Load Balancer. And you see there's a lot of things going on here. A lot of things like deployment of containers. There's auto scaling going on. There's load balancer out there. And when there's load balancer, there is health monitoring of containers, health monitoring of the hosts as well. There's service discovery. There's traffic getting in, so that you need some kind of a DDoS protection from the security perspective. So we're saying that there's a lot of things that needs to be done in parallel. So if you are an engineer doing all of this, um, monitoring just with a piece of code and um, doing a lot of automation, then you need to be like the god of war. So you need to be a code ninja doing all of this. So in order to save time, in order to make sure that you make the best out of the services, you need some kind of a mechanism that takes care of all of these things: the load balancing, monitoring, security, DDoS, exposing your web applications to the internet and all, monitoring the traffic, monitoring the EC2 instances and the containers. You need something that does that. And we are calling that as Orchestrator. Okay. So what is an orchestrator here? What is a container orchestrator? So container orchestrator is about managing your containers, managing the life cycle of containers, specifically in large environments. What can you do with it? You can provision and deploy containers. You can make sure that your containers are available. You can scale up and remove containers. You can move the containers from one host to another. If there is a shortage of any host based resources of the, if the EC2 instance dies, you can allocate resources to your containers. You can expose your EC2 instances and the containers to the outside world, load balance them, health monitor them, monitoring for both containers and the hosts, and configure the applications inside your containers. So there's a lot of things that container orchestration helps you do, which you don't have to do manually. Okay. So orchestration is a generic term. What are the vendors? Who are the providers in the orchestration world, in the orchestration business? Kubernetes. Kubernetes is the gold standard. Yeah. Originally, it was developed by Google as part of the Borg project. And then Kubernetes later on established container orchestration as a de facto standard inside their environment. And then later on, donated to the Cloud Native Computing Foundation. It's also called as CNCF. Now, CNCF is backed by, of course, Google and also by Amazon, Microsoft, IBM, Intel, Cisco, and Red Hat. When it comes to DevOps, the DevOps practitioners have got this Kubernetes a lot in popularity, right? Because there's a lot of things that they can do it themselves to save time. What we are now talking about is slowly funneling down to Kubernetes. So, how does the Kubernetes architecture look like? So we got two components, okay? One on the left hand side, one on the right hand side. You got the cloud, you got Kubernetes control plane on the left hand side, and the Kubernetes nodes. Okay, so the main components of the Kubernetes are the cluster itself, which is the right hand side. Yeah, if you look at the right side picture, there are three nodes here. Those three nodes comprise of a cluster. A cluster is a set of nodes which has at least one master node, and there are several worker nodes. This can be physical or virtual, okay? It doesn't matter. So when we're talking about Kubernetes, it could be on-premise, Azure, AWS, Google, wherever. Okay. So Kubernetes master is the one that is responsible for scheduling and deploying the application instances across the nodes. So it's also called as a control plane. This master communicates with the nodes through the Kubernetes API server. What I'm talking about now is the left hand side picture. So you got the Kubernetes control plane, right? Which is the Kubernetes master communicating with the nodes with the help of this Kubernetes API server. On the right hand side, do you see kubelet? A kubelet is running on every node, right? It's an agent that is running on every node. It's responsible for starting, stopping, and maintaining the application containers based on the various instructions that it receives from the control plane. A kubelet receives all the information through the kube API server. As you might have already noticed in the picture, that if the left hand side box needs to talk to right hand side box, it will talk via kube API server. It means if control plane needs to talk to Kubernetes nodes, it will communicate through the API server. Then there are pods. It's not there in the picture. The pods are running your containers. It's the smallest entity. Each pod has its own unique IP address within the cluster, allowing the application to use ports without any conflict. Then there is deployments, replicas, and replica sets. Again, is it there in the picture? No. So we use usually a YAML file to define the pods and the number of container instances. Okay. So that's the basic architecture here. I just spoke about the important components. One is the node, the cluster itself, which consists of nodes. Then the control plane, which talks to the node with the help of Kube API server. Um, the kubelet, the pods, then the deployments, replicas, and replica sets at a very high level. I'm looking at Q&A. Where is it? Okay. Good question. How many containers can be run in a pod? Ideally, you would run at a 1:1 ratio. Okay. Ideally, it's always 1:1. So it's preferred that you have 1:1 ratio. Otherwise, if you have multiple containers, what will be the problem? If the pod fails, you are impacting all the containers inside the pod. Okay. But technically, you can have more than one container inside the pod. And why does Kubernetes allow that? Well, Kubernetes allows that to make sure that they share the common namespace, like let's say the IP address, the port space. Also, they will also share the same volume. So the concept of pod is to provide certain resources to the containers inside it. And if there are multiple containers inside it, it will provide the same namespace and same attributes to these containers. And those containers can communicate with them easily. But you will prefer to keep them 1:1. Does that address your question? Okay, so there are more questions here. Okay, okay. How many containers can be run in a pod? I addressed that. How pods are communicating with each other. So there is a networking component, an ingress controller that takes care of the networking. There's always an ingress controller. So containers within the pod share an IP address and a port space, and each can find each other via localhost. There is a networking component inside the Kubernetes. It's called as kube router or kube route. All ports can communicate with all other ports without NAT also. They can share the IP address, and if they have the different IP address, they will communicate through regular pod to pod network connectivity. You can have, if you like, you can have layer 2 switching or layer 3 routing setup specifically if you like, that you need to configure inside the YAML file. Okay, so next question. Sumit, I hope that addressed your question. What can be typical use cases of Kubernetes in a payment domain? In a, you mean banking? Or is that some kind of a banking you're saying? Wherever you have a web application ready, yeah, wherever you need services where containers or web applications needs to be quickly deployed and terminated when required, you will have Kubernetes um, deployed. So it need not be payment or banking, but it could be just anything. Wherever you have web applications, it's not specific to a industry. Next question is, where is pod exactly located in the diagram? So it's not there inside the diagram. What I can do is pick up, let's say if I just say Kubernetes architecture, we find a better picture here. This is a zoomed up image. This looks better. So if you look at node 1, right, this is the virtual machine. Node 1 is a virtual machine, and inside that virtual machine you have the pod, and then you have the container. Is it there inside this image? No, it's not there inside this image because it is inside that virtual machine. Okay, inside that node 1. So there's a pod and then the container. Okay, so Varnadatta, is that clear? Is Docker knowledge a prerequisite to start working with Kubernetes? I would recommend you to learn Docker, at least how to create images, play around with Docker on your own computer, on your own system, on your own laptop, where you will say maybe spin up few Docker images. How do you host a web application on your own laptop inside a container? It starts from there, starts from the Minikube environment, where you'll know to manage images, manage containers, uh, delete and run containers using Docker, and then you go to kubectl. No, sir, no, it's not inside kubelet. If you look at the picture carefully here, it's not inside kubelet, right? A container is inside a pod. Kubelet is there to manage your pod, start and delete, etc. Whatever it needs to do with the pod, it needs to do that. Okay, Harbaksh, I understand that the kube cluster scales horizontally by adding more nodes as part of auto scaling. Correct. But is there a way to scale a node vertically in Kubernetes? Yeah. So let's say I've got my EC2 instance. Yeah. Okay. Vertically. So just go to my services EC2 instances. Okay. So these are my EC2 instances that are running, right? So if you want to scale vertically, yeah, you just need to come here and do maybe right click Instance settings. Where is it? Yeah, change instance type. For that, I need to shut it down first and then select change instance type here. So that is vertical scaling, where you are increasing the number of resources on that particular, um, yeah, on that particular instance. We can increase the CPU and memory per app. Correct, Piyush. Yeah, absolutely. So I understood, Piyush. So you can absolutely increase that CPU and memory, and that goes back to Harbak's question as well. Srikanth is saying the container runtime should be Docker in EKS, or can it be CRI.o or any other runtime? Like other runtimes are also supported because Kubernetes is not specific to Amazon, right? It is not Amazon proprietary. It comes from CNCF, so other runtimes are also supported there. Cool. Okay. Superb. So going back to the slide. All right. So that was about the Kubernetes architecture at a high level, where we understood that there are different components at a node level and at a master level as well, and they communicate with each other with the help of Kube API server. Um, so inside that node, you got the pods, and pods are maintained, managed by the kubelet command, which then does managing of your containers. Okay, so let's go do some hands-on to understand this better. Uh, okay, so I'll just get rid of this and go to, let's say, Amazon. Yeah, I'm already here. Uh, okay, I'll close these things which are not required. The first thing that I will do is go to EKS, which will directly bring up Elastic Kubernetes Services. Click on that, give it a few seconds to spin up. Okay. All right, so the first thing that we can do is go ahead and create a new cluster. And you can do this either via a graphical user interface or via CLI as well. I'll show you both. So let's say I just say prod cluster, okay, and then set up next step. A Kubernetes version. There are multiple versions. The latest one is 1.7. Pick that up by default. Then there's a cluster role as well. I have already created a cluster role, but I would like to show you what permissions are granted to this EKS. So I go to roles and oops, let's cancel this and then type EKS here. And then there is a EKS role. So what permissions are granted to this? So this has a permission to manage the cluster policy. So in order to create this particular role, um, one moment, just have to go to create role and then under AWS services, you will pick up EKS, and then depending on your use case, you will select a particular one, and I selected EKS cluster. Okay, the permissions that are required to operate the EKS cluster. So you're granting permissions to your Kubernetes EKS. Okay, so that permissions are granted, and if you'd like to manage an encryption keys, um, and these keys can be in your KMS, right? This has to be created inside KMS first as a key management service. I will just leave it as default at this time. And if you'd like to add tags, you can do that. I say next. I'll put that in my network called as whatever. Yeah. And then the subnet is a custom network that I already created. Security groups, to select any of one of these doesn't matter now in lab environment, but in production applications, you will make sure that you got the right ports open depending from where you are accessing it. So let's say you are accessing it from external world, which is internet, on a particular port, let's say 8080, then you need to have inbound 8080 open on that security group, right? So of course, you can modify this later on as well by going to the security groups and adding it there. But you as a developer must be able to tell the network guys that, hey, I need to have the following ports open on the security group. So the network team then creates the security groups for you. You can then see them in this drop-down menu. Because let's say on a role-based access control model, you will not have permissions to go and modify any of those networking settings or the security groups. We have permissions only on EKS or maybe other DevOps tool sets. Okay, so that being said, cluster endpoints, right? Where do you want your Kubernetes to be accessed from? Public and private, or private? Yeah, and let's click on next. Now, this is about configuring the logging. Very important from the governance perspective, from the audit perspective as well, if you're following certain regulations. So let's say some of us are from the banking industry, as somebody asked that question. You may be following the PCI DSS standards, okay, uh, or FedRAMP standards if you're working for a federal government, or GXP standards or FDI standards. Mostly all of them work together, not work together, but they have the common set of points where they say, hey, okay, auditing must be there, logging must be there for X number of days, right? Are we monitoring it? So you usually switch them on and then control them from, let's say, CloudTrail. If you're mostly for audit, CloudTrail. And from how many days do you want to keep the logs for in, let's say, CloudWatch? It's then managed from the other side. You just have to enable from here. But for now, it's just a test environment, so I'll disable them and click on next. Review. If you're happy with that, just click on next. Okay, so that's one part of it. Another part, now this part will take about 10 to 15 minutes for us to get created. Takes a longer time based on my experience. But another thing that you can do is do all of this with the help of, let's say, CLI. Yeah. So there may be developers in this session today who would prefer to do it with CLI. Oh, what I've done is EC2. Right, let me go open a new tab. Created an EC2 instance. Right, so that's there. So I've created an EC2 instance that already has all the Docker binaries installed, and I've connected to it as well just to save time. Okay. All right, so we can go ahead and run both kubectl commands or the Docker commands from here. Okay. Um, in order to create any kind of images, let's say if I say Docker and then images, yeah. So I've got the following images. There's a hello world image. There's an Ubuntu image. There's another image which is more specific to my subscription. There in a there are no containers running at this time. But what you can do is create containers here, create images here and push those images from here to AWS repository. AWS has a repository as well, just like your GitHub, just like Azure has it. It's called as Azure Container Registry, and AWS has it as well. It's right here, right? Containers, EKS, containers, and then there is a repository section. So containers are used to host your images. So if you look at this picture here, if I do, remember this yellow box that I was drawing? And I did say that, just copy that. I did say that you as a developer have built all the images here, and then they got pushed to some kind of computing power, EC2 instance in this case, right? So the image repository in Amazon is called as an ECR, Elastic Container Registry. For some reason, Amazon has a habit to put or append Elastic in front of everything. Elastic Container Services, Elastic Kubernetes Services, Elastic um, Container Registry. So the image repository is ECR in this case. So when you build an application, you will be pushing that application as an image inside this repository. Again, as always, you can create a repository using the GUI or using the CLI or different other platforms available. So let's give it a name called as image repo, let's say. And just click on create repo. That's created. This is not an image in itself. This is just an image repository. You have to upload images here. Now, as you see, there is no upload button here because images are not in the form of a file on your computer. They needs to be they need to be pushed, right? And here are certain push commands. Depending on the kind of operating system you will use these commands. So this is Linux commands, or these are Windows commands. So since this is a Linux-based OS and I've got images here, I will use this set of commands to push it to my container registry. To summarize this, if things are just too fast for you, I'll just summarize it. Um, we created an EKS, is Elastic Kubernetes Services, uh, and it's still creating. Like I said, takes sweet little time, its own things to do because it needs to set up kind of virtual machines and then containers, set up the whole environment, the whole architecture stack that you saw in the architectural diagram. While that was doing its job, we started to look around repositories, right? Uh, so we said that repository is a place where you can go ahead and create your image repository, where you as a developer can create images on your laptop or anywhere and then push those images to this image repo. So we got the ground set for both Kubernetes. There's a cluster created for repositories. There's a image repo created as well. So while the clusters still being created, let's go and create an image and push it here. Let's see how these commands work. Okay, so I'll go to my CLI. Mm, So I need to pull up the documentation because I do not have a lot of memory in my head to remember all those commands. But one thing for sure, you need to get authenticated. Yeah, you need to get authenticated because you need to first configure it. So let's say I use AWS configure to get myself authenticated, where I have to use the keys. Okay, I will use the root credentials. Uh, okay, okay. Create new access key, and I will use this access key here. Okay, it's my Linux instance. Paste it, and then it is asking for the secret access key, which is available in the IAM again key. Now, do not do this in the prod, okay? Because I'm using my root credentials. It's never recommended. It's a big sin to use root credentials um, in any environments. I'm just using it here, but then in production environments, you will be creating a role-based user, giving permissions to that, and then using its access keys and secret ID. Okay, so US West 2 Oregon is okay for me. Output format, I don't care at this time. So I've set up my keys and access key here. So whenever I run a command next time, it will be using this set of credentials. Okay, so I'm flipping back to, okay, so there are a few questions. Okay, ECR is like a private Docker repository. You're right. It is like a private repo. Okay. Okay, cool. I think the rest of the questions are addressed already. So, all right. So what I have to do is now, while that is spinning up, my cluster is getting ready. I'll just, is it ready? It's just still creating. Okay. So what we will do while it is running is we will go ahead and use the repos. Yeah, we will work on the ECR to create an image. So let's build an image from the scratch. When you do this lab yourself, make sure that Docker is installed. I'll just put this URL in the chat so that you can do this lab offline. Uh, Broadcast message. Okay, so that's the lab that you have to do. Make sure that the Docker is installed, and this link that I just sent will help you do that. It's a step by step. Just copy and paste it. So if I just say Docker and info, oops, Docker info, wait, Docker info. Yeah, it tells me that Docker is already installed. Um, okay, gives me quite of binary CPU 1, total memory 1 GB, etc., etc., etc. So Docker info is the command. Then, okay, what I can do is create a file called as, let's say, Docker file. Typo. So touch is a command to create a file. So if I do ls, the file is created here, right? It's Docker file. Go full screen. Okay. As you see, the Docker file is already created, but I need to edit this Docker file. In order to edit it, you can just use VI editor or whatever editor you like. I'll use VI, or maybe you use Nano. That's okay. So VI, which file? Docker file, right? Okay, I'm there. So inside the documentation that I sent, you will have what content should go inside the Docker file. But what I'm going to do is explain this to you. What is the content inside it? Where is it starting from? Here, right here. There's a typo here. 1 minute, please. This is a C. Okay, not better. Okay, so inside the Docker file, I'm just saying that it needs to get updated, and then I need to have some kind of web application, and I'm choosing Apache 2. So on a CentOS, they're saying that you need to install that package, and then you need to write hello world inside the file called as index.html, and this file will be placed in var www.html folder. So when a container spins up from this particular container, it will be showing hello world, and there are several other binaries that it is executing in the backend. So what does Apache 2 need? Apache 2 needs the following binaries. So we are creating a container with just this binary set. And finally, we are exposing it on port number 80. Okay. So say write and quit. Not here. Okay. So if I cat for this Docker file, right, it's there. What do I do next? You need to build the Docker image with the file. So right now I've just created a file, but we need to build it. How do you build it? You build it with the Docker command. Say Docker and then -t, build -t, and then what's the file name? You can just call it as anything. What is the name of your image? What do you want to call it as? Let's say H world and a dot there. When I put a dot here, I'm just saying that this Docker file is right here. If you look at this Docker file is right here. So I want to create an image called as hworld using this file here, Docker file. That's what it means. So if I run it, is there an error? No, it successfully created it. So if I say Docker images now, there is an image called as hworld right there. Okay. All right. Now the image is there. Now you need to spin up a container, right? Run it. So say Docker, say run, say -t-i. It's an interactive mode on the following port number, which is internal is 80, external is also 80, and then the image that I want to use is hworld. Okay, hit enter. Not reliably determine the server's fully qualified domain name. That's okay. We can still access it with an IP address if its fully qualified domain is not there. That's okay. So what do we do next? Let's try to access this particular IP address. Well, this is a private IP. I need to access on a public IP. There's a public IP. I'll try to access this public IP on um, here. So let's say that. See what will happen. Connection refused. Why is that so? I have port number 80 opened from the internet. It's already open. So now if I say docker ps not running, okay. I hope you can now see this. It's there. So what did we do? I'm just looking at a way to increase the font here. But I'll just explain this. What did we do here? We created a image, a default image, and then we built a container using that image. We exposed that on port number 80, opened the port on the EC2 instance, which is already opened up, and you are able to access it. I hope it's clear. Well, that's okay. -p is also all right. -d is also okay. All right. So as soon as I kill it, right? So if I do Control C, the container is gone. So my web application is also gone. See on the bottom it says connecting, and finally the site cannot be reached, right? So the beauty of containers is that you can spin it up quickly, shut it down quickly, as in when you need this, you can play around the containers. In fact, they scale and they spin up quickly. So efficiency is the key when it comes to containers. Now, let's say this is a production application and you would like to put this inside the container registry. Here, we created the container repository here, and I would like to upload the image to the container repository. Okay, how do I do it? So let's take this image. So if I do Docker images, I have a couple of images here, and I would like to move some of them to, let's say here, right? How do I do that? Because if they are here, then your team can see it probably, and this may be your personal machine, and you would like your team to see what you have deployed. All right, so you can push your image to Amazon Elastic Container Registry. Now, since I've already authenticated using AWS Configure, I don't have to do it again. But like I said, earlier, you can create a repo using the GUI. You can also do it using CLI. Let me quickly show that to you. So I'll clear the screen and use AWS ECR. Okay, AWS ECR is the syntax. Uh, I know the font may be too small, but is there a way to increase the font change settings? Appearance. 1 minute, I'm just increasing the font here, okay? So that you can see it better. All right, it's much better now. I hope it's better now. Okay, so I will use AWS ECR and then use create hyphen repo. Oh, story. Okay, and then you can give a repo name. Repository hyphen name. What's the name of your repo? Um, let's say demo. Yeah, let's give it demo. And then the region where you want to create it. US hyphen west hyphen 2. But you do not have to declare it here because in my configuration, it's already set to US West 2. So I hit enter to see what happens. There you go. You got the JSON output. It's there. So I'll go back to my GUI and refresh it. Okay. I got the demo and it has a unique URI as well. Good. So let's push it to the demo this time instead of mo image repo. Click on that. All right. Now Docker images. Our image is hworld. Okay. So what I'm going to do first is tag this image. Okay. Tag this image. The way I will tag it is by um, using again the Docker command, Docker tag, Docker tag, and my image name is hworld. Okay. I want to tag it with this name. When I hit enter, okay, it's tagged. So now if I do Docker images, I will see that my image called as, where is it? Yeah, demo right here. It's tagged. All right, good. So now I will use that tag to upload it to my um, repository. So I'll say Docker push, Docker push. What do I want to push? This guy, right? Demo. It's already there in my clipboard. Oops. Docker push. That's demo. Okay. So it's uploading. Give it a minute. Okay, looks like it's there. So I'll go back to this demo and see if there's an image here. There you go. So my image is there. Okay. You have any questions so far? There's a question from Srikant. If my organization has its own private repository, those images should be copied to ECR to run EKS. No, it's not required. You do not have to copy to ECR. So if you need to use EKS, it is not mandatory that you should be using ECR. You can use your own repositories, maybe Amazon repositories or Docker repositories, it doesn't matter. It's just that Amazon has given you a placeholder, a service that lets you host it here. Thank you. Okay, so my cluster is also created. Probably should have been created by now. Okay, so that's active. So now you're ready to host web application inside your containers. Use your kubectl commands to manage your cluster, mm, create your own dashboard. I mean, the sky is the limit in this case once you have the EKS cluster created. So, uh, mm, okay. So the recordings, if somebody was asking for recordings, and the answer was that it's gonna be there inside the YouTube channel in the Whizlabs. So one more thing, there are okay, so this is like cut out from here. Minute, please. There are a few more courses on the Whizlabs that will give you a deep dive and more information about EKS and other serverless activities as well on Whizlabs. So you can go to whizlabs.com and look around for the areas of your interest. So if you're a beginner um, in Kubernetes or serverless components, the courses are there. And then if you're an expert as well, probably it will help you refresh your memories and maybe look at Kubernetes from a different aspect. People share their own experiences depending on the environments that they work in and the experience that they carry. So there's a whole lot of material on Whizlabs. And today there is a special offer which I was asked to tell everybody that there is a 75% discount using that coupon code. So what you got to do is once you have selected the course, you need to use Wiz AR75 as the coupon code, and you'll get that 75% discount site wide. So you can pick up any course, need not be the courses that you saw earlier here in this list. You can just go ahead and pick up any course from Islab and still be 75% at that rate. So I have one last poll for today. Um, and it's there on your screen. Hopefully, this session was informative for you. If some of those who were totally new to serverless and Kubernetes, I hope you got an idea about it. Um, and for those who are already there, I hope it was a refresher. And definitely, I thank you all for being participative in this session. Much appreciated. That was really required for me. And also, thank you for your patience while I was troubleshooting the Lambda functions. Right. Um, Yeah, like I said, I always blame it on the demo gods. Before the demonstrations, I should always pray. And in case you do any future sessions, pray the demo gods. But, anyways, um, well, thank you for your rating. I'm very thankful to you all for your patience. That I'm switching back to the Q&A section to see if there are any questions. Thank you, Srikant. There was one question from I don't remember the name, but it was about AppSync, right? You asked about AppSync. So there is a popular language. It's called as the GraphQL. Okay, so GraphQL is more about running API queries using the GraphQL language. What are we doing there? So rather than making requests to various endpoints to get different parts of the data, like a web page, or you may be querying to a single request to the GraphQL API, and you may be looking at a lot of data that's required. So the GraphQL will will be reducing the complexity of the web applications and improves the experience for the website visitors with the faster load times. So GraphQL is rarely a single application. Instead, it's a backend that is usually composed of multiple microservices. So the AWS AppSync itself is an ingestion point, an absorption point for all the GraphQL API calls, which can then be sent to, let's say, AWS Lambda or other sources that understand the GraphQL language. So you can also call it as a GraphQL proxy. It's a GraphQL proxy. It's a service that will receive the GraphQL request, parse the GraphQL request, and then send it over to multiple subsystems where GraphQL can be understood. Do you have live instructor classes at Whizlabs? Uh, that's a question for Whizlabs then.
Hello.
Hello.
Yes, we are. Yes, I'm from Whizlabs, Basant here, and we are planning to have live instructor classes in Whizlabs. So we'll be getting in touch with you. And in fact, there was a poll. So just let me start the poll. If you can see, if you guys are still there, are you interested to participate in online live training? Okay. Thank you. Thanks everyone, and hope it was a learning experience for you, all of you. So we have got quite a lot of yes. Okay, so we are definitely planning for it, and we'll be getting in touch with you soon. Hello, Anand. Over to you.
Hey, hi. Yeah, okay. Well, like I said, thanks all for your time. We scheduled it for 2 hours and we exceeded a certain time limit as well. Much appreciated for your patience. So, I wish I could show more of the demonstrations on the EKS and the containers front and Lambda and other entities as well. But then time is a limiting factor, specifically on the weekends. But like I said, we'll have more sessions through Whizlabs and we'll stay connected through this community and forums. Thanks all for your time. Have a wonderful day. Take rest and stay safe. Bye for now. Thank you. Thanks all. Thank you.